So what I want to talk about really is how we get geoscience, however we define it, let's keep it broad for now, across to the public. And I want to start with that because I think there's some interesting issues that we have to look at in terms of both the geoscience at its broadest, and then I want to be specific about geography. And I've got that thing, new rules for public engagement, because it seems to me that there's lots and lots and lots of issues that are coming up that are going to be taxing us in a kind of geographical sense. And I'll dwell on one of them in some detail. So yeah, let's kind of move on. On April the 1st, 2009, there was a magnitude 2.2 earthquake near Blackpool. Set a little tremors. First, it very quickly became apparent as seismologists looked at it that this was at the site of the drilling site of a company called Quadrilla, who had been just starting the process of looking at doing a test well for shale gas. In fact, that was 6 hours. 6 hours into the start of drilling in that site at the UK where the earthquakes were triggered. And suddenly, although the company denied it, it was very clear that the UK public had been introduced to hydraulic fracturing. Fracking. And I'll come back to what that process is particular, but I suspect everyone in the room doesn't really need to know at this stage the generalities of that. So fracking announced itself to the UK public in a very particular way. A seismic tremor of 2.2, by the way, is if I asked the first half of this group to jump up and down, the vibrations I would feel here is a magnitude 2.2. It's the same size of earthquake that the post-mining earthquakes get in this area all the time. So clearly it wasn't the size of the earthquake, it was something about it, particularly the idea that it had been a man-made event. But certainly, well, what happened next from magnitude 2.2 was quite extraordinary. Immediately, local groups got up in opposition. This is the Ribble Estuary Anti-Fracking Group. And apparently they came together very quickly because they're the same group that opposes wind farms. And there's an interesting, irony there. But this then spread even further, really, in terms of the kind of perception of this new phenomenon that was sweeping the country, and ended up in the summer, last summer, with Balcombe and the protests then. So this was suddenly kind of front page news. So one of the interesting things at this point is when science, so this is a phenomenon that people haven't heard about, and then suddenly it's thrust upon them in the news, etc. And at that point, it's very hard to get the scientific detail across to the public because you're in a confrontational news environment, and suddenly it's a very different atmosphere to the one that we would normally gradually hear about something. And that's quite interesting. So one of the things that interests me as a kind of geocommunicator is what do the public know about any of these issues, but I'm really going to concentrate on shale gas today. What do they know? In fact, we could go on to this. What do they want to know? What do they need to know? But let's kind of think, what do they know? Before we look at that, in terms of what we do, what do they know about geography? One of the things is, what do they know just generally about science? So there are science literacy surveys that have been done for the last few decades. And here's an example of the kind of questions that get asked to adults across Europe, across America, through for the last few decades. So these are basic facts of knowledge. Centre of the Earth is very hot. True or false? True? Who says true? Oh dear. I see many hands there. You could look at these and decide yourself whether you think you're shocked by it or not. There's the continents are moving slowly about the surface of the Earth. They did a whole series on that. Only 72% say that's true. About a fifth of them say they don't know, and almost a tenth of them say it's not happening. Common salt is made from calcium carbonate, causes much confusion. Earliest humans lived at the same time as the dinosaurs. So here's the thing, is that this kind of data has spawned a notion that the public, and in this case the UK public, have difficulties when it comes to science. Technically, their knowledge base is comparatively low to the level of what we would necessarily anticipate them to have. So that means as soon as you start to communicate science, you've got a problem, because sometimes some very basic things, like oxygen we breathe comes from plants, some very things that we just take for granted are not there in the public realm. And the interesting thing is that the surveys of the public they realise this. They realise they are technically deficient in the knowledge that they need for most of the issues of today. They acknowledge that quite openly in the responses to surveys. The question really is what we do about it. What do we need to do? I've got some sympathy for the public in this respect, though, because one of the things, if you think most people's science, if you think back to your science, came from a bit of physics, a bit of chemistry, or a bit of biology at school, one of you were probably comfortable with one, maybe, or two. Some of you may be comfortable with three. Some of you may have been comfortable with none of those. But let me show you what science is like today. This is science. This is science as defined by the interactions of the web of knowledge, the scientific basis. Here's geography. Human geography is up there, environmental science here, geology is down here, kind of a spread of values, a spread of kind of nodes. And the point I wanted to show is just how science has exploded in its technicalities across the world, across the domain really. And I'll bet you in every one of those hubs, there's scientists bemoaning how stupid the public is in not knowing the basics of what they do. And I know that if I had to suddenly start talking to you about stem cells, we could wrap up now and we could all go do something. So the issue of the public being stupid and having no knowledge is the wrong one. They don't have our knowledge, and that's a different thing. So one of the issues really is that, what do? Do we try to get the totality of knowledge across to the public? And as I will say in a minute, the public actually aren't very interested in this, in science. They're kind of interested in science, but they're not interested in getting involved in science. So let's deal with this thing about the public, because actually the public isn't the public. There's a whole suite of different groups in there. And one of the interesting things, there's lots of ways of cutting that cake of who the public are, who the stakeholders are, etc. So I'm going to use a very simple one that science communicators tend to use. And that is that one group is what's called the science attentive. That's you lot. You'd be glad to know. You're science attentive. You're quite close to science, by and large. You feel quite comfortable with it. You could probably hold a conversation about it in a pub or a cafe. You'd read maybe New Scientist or Scientific American. You watch scientific documentaries. But that's only about a fifth of the population. Then there's the science interested, a bit farther from science, maybe a little bit further in the past, or maybe a little bit of a more of a tenuous relationship, like science, but probably wouldn't be buying New Scientist in Scientific American. You might read the odd science article in the newspaper. You might watch a documentary, but be sufficiently interested. About 40%. And then, of course, there's the great unwashed. The non-attentive public, or some say pejoratively, the science illiterate. And that's the majority. And they will quite happily say, look, it's not for me. Sorry, I didn't like it at school. I found it too hard. Forget it. I don't even know who you are. Apparently you do some documentaries. I've never seen them. I'm sorry. Now, some of you at this moment are thinking, well, Iain might be literate, but he's not numerate. Because that doesn't add up to 100. And the interesting thing is, if you take this group here and you subject them to the basic science test that we saw, it's called the Oxford scale, they fail. And half of them disappear. They're actually in here. In other words, that group is much smaller. They think they know science, but they're severely misconceived about science. So what we end up with is that we have a small group here that really likes science, a small group here that could like science, given certain caveats, and a group over there, the bulk, that don't like science at all and are not interested in it, and make it perfectly clear to us. I kind of think of this as BBC 4, BBC 2, BBC 1. But here's an interesting question then. So I'm making a documentary. Who should I aim it at? Which of those groups should I aim it at? Who thinks I should aim it for the science attentive? Oh, that's interesting. Science interested? Yeah. The great unwashed? Yeah. Yeah, I'd say so. I mean, I think that when we make a program, we're in here somewhere because we know that they're capable of being interested. So thinking about if we set it in the right way, we should get them. But of course, that's the great challenge, is the ones that say they're not interested. There are much huge about, if you can shift them to the left from watching BBC One across to watch BBC Two to watch one of these things, then that's really good. So, for example, Hazel mentioned the sinkholes programme. Of course, on the morning of the sinkhole, the day before the sinkhole, the bottom fell out in High Wycombe, my car went down. I was on the one show, I was on a few other things, and suddenly we had 1.9 million watching versus 1.5, which is normally the typical for these programmes. So we had 500,000 people because we'd appeared on BBC One and on Radio 5 Live and all the rest of it, brought some across. The key thing, though, is that it's not for you. These aren't made for you. They're not made for your students. They're not made for the academics, the students of geography and universities. They're not for you. And the reason for that is very unfair. We've got you. You will watch them anyway. So if you really kind of get pissed off with the noise being too loud in these things, or it jumping around, or the signposting that tells you constantly what's happening, what you remember, the reason for that is that it's not for you. I apologise, but it's to try to get this lot across. And that's one of the misconceptions we have that I'll try to kind of deal with. So the key thing then, the key thing to bear in mind is that there's a huge proportion of the public that are scared of science and not very interested in it, I don't think. So, so basically, flicking around. For the last 10 years then, I've made a whole series of kind of programs exploring different aspects. And the key thing that I wanted to deal with now is what is the essence of getting that across to the general public? What do you absolutely need to do? There's kind of five rules, five characteristics is probably better. But I think that if you're trying to get across to that broader audience, then you need to kind of deal with. And the first one is you need to entertain. This quote here basically says that I am in the entertainment industry. When I do a program, I step out from being an academic, I step into the entertainment industry, and that's the fact about it. If I don't produce things that are entertaining, first and foremost, I'm not doing my job in that realm. And so one of the things, and this talks about scientists, but realizing that if you want to communicate in a popular style to as many people as you can, you have to start thinking about the entertainment industry and what works in that context. So that's that classic shot of the Devil's Pool at the... people are asking me what I was doing at the... This is Victoria Falls when I kind of climbed up on that lip there. But as you can see, the locals are doing even more extravagant things there. So what I did was quite tame. The other thing you need to do is dumb down. Except it's called simplification. It's that notion that every one of us should be able to take complex ideas and break it down to the fundamental building blocks and build them up in whatever way we can. We should be teaching. This is a generic skill that we should be teaching in science all the way across. Most of us have touched on it, but often it's not explained in this way. I suspect when you come out of a kind of sixth form class and you go in to teach your kind of the junior years, you never say, I'm off to dumb down with a year kind of sixth. The point is you expect different things. You have a different language, and telly is just another set of things there. So we have to learn how to simplify. So here's an academic, and that process that he's going through, the words coming out of it, with thoughts in his brain, to the words in his mouth, to that microphone, to essentially that camera, to 2 million people, is a process of simplification. What else? We need to tell stories. And there's every one of the BBC kind of science producers up till a few years ago went on a Hollywood script writing course to learn how to tell stories. And this is a quote from happens to be a paleontologist. But I like this. Popular science too often seems like castor oil, something we should take because it's good for us, not because we want to. And that's classic about things that is made with climate wars, where it's sometimes quite earnest, important stories. Things that we think the public should know. But the key thing is to remember they don't need to, you don't have the right to demand that they know these things. You have to connect with it, and the way to connect is tell them stories to bring them in. You need to make it personal. Humans, I love this quote. It's actually been papered myself and a guy called Ted Neal, but it's Ted's words, and so I've quoted it, I think, in full. It's a fact often overlooked by scientists that most other people are mostly interested in other people, and they're mostly not interested in anything else. The fact that scientists are more interested than average in things and ideas marks them out as mentally unusual. when you're in the bus and you're really annoyed because the people around you are sitting reading OK magazine or whatever it is, hello, that's because people are interested in people. And you know, Hazel's already made the point about the connection with geography, with people, and that's fundamentally important. You know, people relate. This is a guy that was took us out in the ice in Greenland. Traditional fishermen, we were there as the ice floes broke up. That was a month earlier with climate change. And I said to him, you know, do you sense climate change? Do you see it? He said, oh yeah, absolutely. A month earlier, you know, I can't go out in the ice. This will be the last day I'll do it, and I'll completely change. I said, oh gosh, is that terrible? No, he says, brilliant. Really good, he says. Because he says, for most of the winter, I'm lying on a hole beside the ice with a gun, waiting for a seal to pop his head up. When the ice goes, I'm out in my boat catching loads of fish and I'm in loads of money. We didn't broadcast that, but the point was that people, that's a way into talking about people's kind of connections. And the last one is making sure that we just don't let the science get in the way of the excitement and amazement and wonder of what we do. This is the wave in Arizona, one of the most famous kind of places. It's a sandstone sculpted by wind. That's all it is. It should be the most boring thing in the world, and yet it looks spectacularly beautiful. And we shouldn't just forget that there's bits of the planet that look absolutely beautiful. So the thing is that geography has these in space. All these elements are elements that it just flows out of geography. And because of that, I think there's tons of geography on telly. You kind of know all the. I mean, I've just taken a collection this morning. There's the big epic things like Human Planet and Planet Earth. There's lots of presenters that are talking about various aspects about geography. So Helen Chersky and Kate Humble did Orbit, and then did something about the Sun. Simon Reeve there, Bruce Parry and Michael Palin. And there's programs like the kind of expeditions type thing, Lost Land of Volcano and Operation Iceberg. And there's a new one that's going to appear soon on your screens in a few weeks called Cloud Lab, about a group of scientists that go across America in a balloon and do all sorts of experiments. There's tons of geography. But it doesn't seem that way. So often I talk to geography teachers and they'll say, why isn't there more geography on TV? Or they're quite critical of the geography that is on TV. Some of the criticism is often aimed at the personality. They say, well, they're not geographers. I don't think that's such an issue. If you go into any geography department in this country, half the people in there will not be geographers, as Hazel said. That idea of crossing boundaries is fundamental. We're not precious about that. I get the sense, talking to people, that the essence of their kind of dissatisfaction is the substance, is the feeling that it's quite superficial, that it doesn't, that for you guys in this room, geography has a bite to it that you see is missing in the kind of television output that's done geographically. And that's really what I want to kind of address, really, because what I want to talk about then is how do we get, or think about how do we get some real bite across. So I'm going to start with a test, though. Here we see this classic image of Eastern North America showing the kind of industrialized East versus the kind of the Western USA. And this image gets used in lots of examples of talking about global, the kind of industrialization of the kind of world. And here we see, so you can see, for example, there's Denver, Salt Lake City, where's that? Okay. Whole room of geography teachers. Fantastic. Where's that then? Minneapolis. Nope. It's not Minneapolis. It's not in Canada. Canada starts just a little bit higher when the lights go off. Now this is shocking. Shocking. Everyone in your students should be saying, doesn't even know one of the major cities in North America. And of course it's a trick because it's not a city. It's a place called Williston, and that are the lights from shale gas. Seen in space, the flaring off of gas in the top corner of North America, showing you the huge concentration. That is now the frontier of the kind of shale gas fracking circus in North America. And just to kind of highlight that then, that's where we were, the Williston Basin, so-called the Bakken. And shale gas in North America in the 80s was started here in the Barnett in Texas, went to the Eagle Ford, crossed into Haynesville, kind of wound its way up here, got into the Marcellus. You've probably seen lots of stuff talking about Pennsylvania, etc. Huge arguments there about New York State, which has got a moratorium, and Vermont, which has got a moratorium. And then it kind of switched across to here, but at the same time, all these places here have kind of kicked up. And that is a map that every one of you should know, because that is a map that's changing the geography of America, and with it, it's changing the geography of the planet. And that's really what I want to kind of move on to. So, fracking, we haven't really kind of said what it is. But what it is at depth, and at depth will vary, but typically a couple of miles is, or 1 to 2 miles, say, is pretty average. There'll be a shale formation at depth, and that shale is enriched in carbon, and it's got lots of inherent gas in it. And normally in geology, what would happen is that gas would leak up out of these formations into sandstones, etc., higher up, where they would drill into and get. 2 bits of technologies come along that allows us to directly get it. One is the idea that we can drill down now, and something that was developed in the North Sea is that about a mile or so down, you can just turn the drill hole and go horizontally. So we can run along the quite narrow horizons that would have the gas. Previous to that, you'd just go through it and it would be kind of, you'd just only have a few meters, or tens of meters. And then the other thing, again, it's been worked up a lot in the North Sea, is then injecting down millions of gallons of water to crack open this rock. Now the thing is that there's something like 2 miles, well, at least 2 kilometers of solid rock pressing down on that. So you go open a crack, it closes immediately. So one of the things that needs to be done is alongside the water, you need to put lots of sand down. And the other thing is to keep the water kind of viscous, to give it a punch. It needs to have a bit more viscous, so we put chemicals down. And those chemicals also stop the fractures from algae and bacteria closing and clogging up the fractures, so you keep them kind of clean. Now that process, collectively, is what we kind of refer to as kind of fracking. So they start off with is a drilling rig like this, sits in for about a month, drilling down, doing this hole, and then what happens is that disappears off, and you end up getting, there's no drill rig here, you'll see. What you get is a set of vehicles. This is the frack pad. Notice the contrast very abruptly between, I was going to say wilderness, probably isn't wilderness, and a kind of frack environment, frack land there. And then you have all this paraphernalia piled in. These are compressors and pumps. That's what all that's for. There's your actually drill. There's a drill hole there. And all this stuff just injects, say, millions of gallons, but 3 to 5 million gallons of water for an individual frack job down, cracks open the rock, and you can do that multiple times, but it needs equally the same amounts of kind of water. I'm going to go through this quite fast because I want to get to the kind of bigger points beyond this, but we can come back to any of these things. It takes a lot of water for just the reasons I've said. So there's water coming in, but this gets used. It gets used again. They use the water to refract, to frack again sometimes. So you end up with a lot of wastewater that's heavily contaminated, and often with chemicals and also often radioactive materials that needs to be taken away and dealt with. In the US, what they do is they inject it down wells into the subsurface. And in many places that causes earthquakes and all sorts of problems. You need lots of trucks, unsurprisingly. Trucks for the water, trucks for the sand, trucks for the chemicals. All of it coming into these frack pads, and when it's done one place, then they all move off to somewhere else. So you're constantly get this kind of, as I say, kind of a circus of trucks. And what are you left with? Well, when the whole thing goes, you can see, you'll see, this is in Pennsylvania, there's kind of a pipeline, it's not a forest break, the line where the pipelines go, and you'll see tucked away in various places, you'll see this, which is a frack pad. Basically, these are kind of, these are to collect the water. There's an irony that most fracking wells actually produce more water than they use, because over the next few years, all the groundwater that's down there just is gradually seeping out, so you need to collect this off. So the water collects in here over the years, and the gas gets collected in that little thing there and gets sent off into the gas pipelines wherever it goes. So you're kind of left with this. And one of the aspects is, at some level, that doesn't seem very much, actually. But the question is, of course, this occurs across, many of them across areas, and what do people make of them in their backyard? Well, there's not been much work done on this, but this is a kind of review of whether people are positive about it on the right or negative on the left. And these are two counties. This is in the Barnet in Texas. Wise County's had it for quite some time, 6-7 years. Johnson's had it for a couple of years. And the main reason for showing you this way is you'll see it's skewed to the left. So broadly negative. But let me just focus on what particular bits are the negative. So I'm just looking at the top part of that graph. Well, the top one, increased truck traffic. So here's a double-edged sword with fracking. Beautiful new road. Gorgeous new road. That would have been a rubbish rural road until a few years ago. Beautifully tarmac, but of course, that's because lumbering trucks going along it. People worried about the amount of fresh water used. Often in agricultural areas, of course, agriculture uses a huge volume of water, but that sense of competition with this industrial process suddenly coming in irks people. Consideration of high tax rates, not quite sure what that goes. Depletion of aquifers, noise pollution, water pollution, traffic accidents, again relate to this here, loss of privacy, this idea of new incomers, this kind of notion that it's not the same place as it used to be, lots of strangers around. Hard to get into schools, for example, because suddenly lots of people are there. Hard to get accommodation. Local people can't afford to buy because all of this, other people are coming in. There's environmental quality and potential land use. What about the pros? Well, not many of them, as you saw. Got jobs. Availability of good jobs, top. Fire protection, well, these are all services. So these are for rural areas who's often got a school or a community that's kind of dying, and a school that's maybe on the verge of closing, or a local hospital that's on the verge of closing, and then suddenly an injection of capital. For example, Pennsylvania, 25% of the gas revenue goes as a schools tax, goes straight into the schools. So if you are someone who uses these services, you will see a benefit from that. You'll see it as a positive way. But you'll see broadly, it seems to be skewed kind of negatively. One of the reasons for that is images like this. This is a famous one from National Geographic of the lady, and I hate it when this happens. You turn the tap on and suddenly it just big, huge flame jets out of it. We actually filmed in this house, and we couldn't get that to work, but it wasn't because it didn't happen, it was because we were there in the afternoon, and it kind of leaks. If you use the tap, it kind of leaks away. So they were saying we should come first thing in the morning, and then it'll kind of really work. And as we left, not having managed to make it done, the husband ran out and said, "I can make the kettle burn," but that wasn't enough for us. So here's the house, and this is the thing that dominates, is this notion of the effects on air quality and water quality. So at this house here, there's a borehole for water. And this is a guy from Duke University, Rob Jackson, testing the water, and that water is absolutely full of gases. You can see it bubbling. It's kind of like it's literally kind of a fizzy water. And that is, but the issue here is that has been happening in that area for decades. In fact, in 1990, before fracking got anywhere close to Pennsylvania, there's a report from the Department of Environment there telling people how to avoid build-up of gas in their homes and kind of release it. That's because the Marcellus Shale, which is underneath here, is absolutely packed full of organic material that over millions of years, hundreds of thousands of years, has been leaking out and leaking into everything. So there's absolutely no doubt. This guy, the Duke researchers are the ones that have done most of the testing, environmental testing. And what they find is they do find gas in water supplies. What they've never found is fracking fluids in water supplies, which leads them to the feeling that what is happening is that the boreholes are going down, and as they've gone down, instead of protecting the near surface bits with concrete cladding, which you're supposed to do for the uppermost few 100 metres, to avoid the standard drilling procedure, shortcuts are taken, and they don't get clad properly. And what that means is that the gas that's inherently just leaking out of the rock leaks in to those pipelines and goes kind of straight up like a big game of snakes and ladders. What doesn't seem to be happening, or there's no empirical scientific evidence for, is that process is 2 miles down. It cracks open the rock is allowing fluids to kind of somehow rise up. And that's the thing that's still out there. So there's no doubt that there is contamination, but most of it seems to be from bad well integrity. There are frac fluids being found in groundwater, but they've been found from oil spills at the surface. And this relates back to this idea of traffic accidents. Trucks coming along, have an accident, spillage, and that spillage seeps down into kind of water supplies. But what I'm trying to do is show you is the kind of complexity, really, of this issue. This is Janet McIntyre, who we interviewed, who actually is severely, her and her husband, severely ill. A whole cocktail of illnesses, even up to leukemia, which are very hard to kind of pin down in terms of toxicology. That all started when essentially her groundwater from her well that her husband drilled, who's a drilling engineer, outside their house, suddenly went purple and frothy. Such that now they don't use any of that water. In fact, they get bottled water in, and she, every day, goes round her community of woodlands delivering bottled water, because the community used to all get water from her house, and now none of them do, and many of them are ill. And that only started when a fracking job started about half a mile away from their house. And the husband is absolutely convinced, he says, I'm a driller, I know how this works. They screwed up. They messed around with that drilling. But they can't prove it. It's very hard to connect these things up. Very few health studies actually can show this. Here's C.B. Leatherman. He's got a little smile on his face. He's a shaleonaire. He lives in Louisiana. When the gas company came and said they wanted to go underneath his land, his first check was for $450,000. He gets an annual check of that just for the revenue of the gas every year, just sitting there. Fundamental difference, that doesn't happen in the UK. You don't own the oil and gas rights underneath your land. You own the mineral rights, but you don't own the gas rights. Her Majesty does. It's a lovely image of her drilling for oil underneath. That's the. So this is Pittsburgh. There's a huge industrial change happening in America. A lot of the companies are coming back, particularly chemical companies that use a lot of gas, not just for energy, but also for the actual product of the chemicals. So when they get surveyed, places like this get surveyed, do you think the Marcellus Shale is an economic opportunity? You'll see that the yeses are the dark blue and the kind of medium blue. They dominate. So this is clearly an economic boom. More interestingly, if you ask the question is, do you think it's an environmental public health? Well, here, I look at this side here. These are the ones that are saying significant. That is a fair number of people. In some cases, especially when you go into the rural areas, so Allegheny County is Pittsburgh, where fracking's banned, interestingly enough, but they quite like it. When you go into the rural hinterland, this goes up. These are the people that confront it. And I think what there actually is there is that people are saying both things. They're saying, yes, I agree, it's an economic opportunity. And yes, I believe it's an environmental and public threat. So the idea that a black and white, yes or no type thing, just really doesn't seem to exist. Here's the reason why it's important and why this is, everyone should know this. This was the expectation from the 2001 Annual Energy Outlook about what was happening to fossil fuels. They were all going down. This is the US ones. Offshore, that's Gulf of Mexico. Onshore, again, unconventional. And everything was dropping down. People were talking about peak oil. People were saying this is going to drive renewables and a kind of move into a great climate future. And then shale gas came along. So America now is self-sufficient in gas for 70 years at least on what they already know is in the ground that they can get out. That has changed the landscape across the world, that particular figure. It's changing in other ways. US isn't the only one that's got it. Shale gas is different from traditional oil. So the Middle East, for example, has got very little shale gas, or it's not very interested in it. Instead, some of the big players are going to be Argentina, South Africa, Australia. China's got lots. You can see in there Poland, for example, in Europe, looks like a big place. What people are saying is this is going to change the geopolitics of the world. In fact, one MD in a gas company, and I'm not sure if you did believe it, said America will now not get involved in Middle Eastern wars. It's got no interest. It's got no interest in the Middle East because it doesn't need it. It's suddenly got all the stuff in its backyard. Interesting questions about what it means, for example, about America going into the Arctic as well. But the issue is that everyone has shale in their backyard. So suddenly it's a a source of fuel that could get that other people can use and can free them, if you like, from the kind of the stringent sources that they've been relying on for so long. But the real kind of really contested bit, or not really contested but complicated bit, is that this is the carbon dioxide emissions really in the States now. This is what it's been doing over the last few years. It goes up and up and up and up, and then it's gone down, it's dropped sharply. And you can see what's done it, because here's all the different different contributions, and all of them are going up except for one, and that is coal, this blue one. Coal goes up and then sharply drops off. Basically, shale gas got so cheap that for energy, coal couldn't compete. So it was gas that America was burning for its energy, and the coal companies couldn't sell it to the domestic market, they had to sell it abroad. And the net effect of that is something extraordinary, is that the US CO2 emissions are dropping. So 98, that was the expectation. Who would have thought that America would actually be able to reduce its carbon dioxide emissions? And yet this is what actually happened. And one of the problems, of course, come back to, is the fact that that is happening because America isn't burning its coal. It's exporting it, so someone else is burning America's coal. So let's go back to Britain, because we've got gas. There it is. Oh, that was. There it is, bubbling away. That's a piece of shale from Bowling Shale near Blackpool. It's what Quadrilla drilled out. You can see the thing there. There's an interesting thing about that. So that is packed full of gas. It's been taken out of the ground at high pressure, put straight into water, and the gas is going, oh, thank goodness. That's gas that's been in there for 300 million years, coming out, going, thank goodness, it's like a genie in a bottle. But interestingly, notice it's not coming out from the whole shale. There's a zone there, here, nothing really in there, there's a little layer there, and there's a bit there, and there's a bit there. And that really is the nub of the point. In the UK, we don't know if our shale is actually good for gas. Some bits really are. Fantastic. Some bits aren't. But the variability is such that until it goes down and drills, there will be no knowledge about what that is. Trying to predict it is going to be really hard. If most of UK's shale gas is like that, you can forget it. If it's like that, it's absolute boom time. Chances are it's going to be something much more difficult in between. But why am I saying all that? Why? One of the fundamental issues that I think we need to kind of get past with shale gas is where it sits in the broader energy portfolio. This is the national grid. This is the place that keeps your energy going. It's the place that sits and watches as you suddenly make a cup of tea after EastEnders and suddenly brings on a hydroelectric power station somewhere in North Wales or western Scotland. So we have, there's the demand up here. You can see the different proportions. So 31% is coal on this particular day. Nuclear 15.3%, that's gas essentially, combined coal gas turbine, 35% in wind, 8%. And if you look at a typical day, this is a Sunday, February in 2013, you see blue is coal, red is gas, nuclear is green, and wind is purple. You can see the problem. The bulk of our energy comes from fossil fuels. It comes from coal, the biggest chunk, and it comes from gas. And then on top of that, the other base load that's really important is nuclear. You can see that wind creeps in at certain times when it's kind of needed, but it's relatively minor. And then if we go across the year, you can see that even more dramatically. They're just little hints of purple. Hydro is a luxury. It gets turned on once in a blue moon when we really, really need lots of energy, just as a sudden kind of injection of electricity. What's interesting here is you see us, our lifestyle. Here's Christmas Day. I know that is Christmas Day. And that's Christmas Day. Factories are shut. No industry is using it. All the offices are shut down. We're not using energy. And yet, in other times, clearly, we're using lots. But the key thing is, look how dominant those reds and blues are. When we're trying to talk about our low carbon or ideal or decarbonised future, that's what we're trying to take out. And if you don't like nuclear, you can take out red, blue and green there. And that's the problem we have. How do we shift that across? So the point is, in the UK, we've got rid of coal. Coal's died away. And just last week, the last 3 deep coal mines were kind of shut down. That is a dead industry in most people's eyes. And it's gas more than anything. Look, from nowhere, the red line, up, bang, that's, a lot of that's kind of North Sea, but that's dominant. Nuclear is the blue one here, kind of rises and falls, oil's on the way down, and that one there is hydroelectric, and the blue one is renewables that don't include that, creeping up. What's going on with the gas? Well, the main reason is it's not from the North Sea. You've got all this fantastic independence debate going on based on the oil and gas revenues in the North Sea. I wish you'd have a look at that. That is the projections of what's happening in the North Sea for gas. You can see that it's risen, but it peaked in something like 2002, and it's a downward decline. And that means that really we are now a net importer of gas, and really have been over the last few years. So we get it from the North Sea, we don't get enough of it to satisfy our demand, we have to bring it in. And that's the kind of issue. Where are we bringing it in from? Well, we bring it into places like Isle of Grain, a couple of these LNG big complexes. That one's in kind of east in Kent, and it comes from a lot of it comes from these huge tankers that come from. Well, most of ours come from Qatar, but they come from all the way around the world. So somewhere in Qatar, they extract gas, they compress it using great amounts of energy, compress it, put it into these container ships. Container ships come around the world and they drop it off places like this, and Isle of Grain typically has 2 weeks of gas for the UK. That's what it is. It needs a constant supply injection of these things. But as this demonstrates, at any point that ship can turn around in the ocean and go somewhere else. It's the biggest, highest bidder. So gas, it could be earmarked for the UK. Someone in Japan says we'll pay higher price, off it goes to Japan. This is part of a global energy network that we are kind of at the end of. And here we are. It doesn't all come from abroad. We get imports into the EU from North Africa as well. We get some through pipelines in this way. Norway has got a special interconnector into the UK. But the really big one is Russian gas. It's hugely in the news. This is the gas pipeline through Ukraine coming into here. And we are just one player in a complicated set of markets at the end of all those connections. And who is paying the biggest kind of price for that? So I don't have to tell you how important, for example, some of those geopolitics that get played out in Ukraine are at the moment in relation to how we think about our energy. But there's another thing on too. We know our energy mix is changing, and everyone in this audience will have a different view of where they stand or what they like in terms of energy, what they don't like. But the reality is, we kind of know what's coming up in the next few years. These are big projects. They don't just appear in nowhere. We know what's getting built. This line here is the line at which the demand is placed. Okay? That's the typical demand that we need in terms of our energy. And you'll see that at the moment, it's accommodated by coal and gas. These colours are switched around in this, just to annoy you. And you can see there's a bit of nuclear, a bit of oil, and these broadly are the renewables at the top. And over the next few years, you'll see that that proportion of fossil fuels will drop. They'll drop largely because the coal power stations get phased out for European regulations, environmental regulations. And nuclear drops a little bit because some of the nuclear power stations are coming to the end of their kind of life. And you can see that there's obviously other things coming on. There's more onshore wind and going on. But what's the net balance there? Well, this graph has the zero line here is that demand line, and the red line is essentially our spare capacity, how much extra we have on top of demand. And you'll see that right at the moment it's about 15%. We can call on 15% extra energy than what actually typically we would use. But what you see is that over the next few years, there's more losses to our energy portfolio than there are additions. So these are the new types going on with biomass and renewables, and these are the fossil fuel ones going out. What it means is that spare capacity drops and drops and drops till it's about 5% in a few years. And people are saying, that's all this stuff about the energy kind of crisis. People are saying all it needs at that stage is either a really, really bad winter when we suddenly decide where our energy usage goes up, or it will be an international incident where we suddenly can't get the energy that we need, i.e. something involving gas particularly. So those are the context that sits behind all of the stuff that I'm talking about. So where am I going with this? Well, of course, the other thing that I haven't even said anything about is climate change. It's alluded to all the way through. We have the most stringent targets in the world, 80% reduction by 2050, and well, this is blue, sorry, is Scotland. It's slightly higher in the short term, 42%, 34% by 2020. And I'll just get the 2012 ones. At the moment, they're going up. And the reason they're going up is because we're burning coal again. We're burning coal. We're bringing it, and the reason for that is because it's cheap and because of the energy prices that's out there. So one of the issues that we've got is here are the people that are really concerned about shale gas. Is that one of the issues that as a collective community we've got is how do we tell these people, how do we give these people the knowledge base on which they can base these decisions that we're all collectively going to have about how our energy future is like, to what extent do we go for climate reduction and climate zero carbon or decarbonised futures. These are highly complex issues, moral issues, ethical issues, but also technical issues. In other words, you need to have this stuff. And I would say that in terms of just say shale gas, you cannot understand shale gas without understanding it from right down at 2 miles all the way up to the surface and all across the world. You need to know, and this is why I've been specific there, in terms of you as geography teachers and people asking you, you need to know about earthquakes down at 2 miles. What is a magnitude 2.2? What is it doing? How important is that? You need to know how does the fluid and gas move through solid rock? How does that really work? You need to know about technical capacities of wells, because that turns out to be really crucial. You need to look at and be thinking about how, what is the increase in traffic? What are the chemicals that these things are actually coming through? What are the communities like that these places are like? How stable are these communities? Are they complicated communities? Are they very simple? This is a huge, huge set of things. But if you just concentrate on one little bit, you're missing the bigger part of the picture. And that's really difficult. It's really difficult to have that totality of understanding. And what we tend to like is we tend to like a little bit over here that we're really good at, and we kind of acknowledge those other areas. Unless we really understand the whole thing, we're not able to be providing guidance about informing others. And that even gets more if we then go to, and that's an audience that's interested. The bulk of this audience, they're not even looking at us. They're not interested, but they will become. In 2 weeks' time, British Geological Survey released the southern part of their assessment. And suddenly that's the shale gas licenses in southern England and central England. And that politically will be really quite interesting because obviously the Conservative Party have been very ebullient really about its support of shale gas, and we'll suddenly find those Conservative constituencies in Middle England and the Shires with shale gas in their backyard, and that might change. But one of the big issues is trying to avoid this black and white, this yes, no. These are shades of grey, really complicated. And it's this idea of us trying to deal with all of these. And so I just want to broaden out really again this idea of crossing boundaries. Because I don't think there's anyone in this audience, probably just that section that I've just talked about isn't sitting there going, that's geography. Every inch of that is geography. And it is, of course. So one of the issues is that we've got this, most of our challenges that we're going to have is this connection between what's happening in the physical, natural system up here, climate change, etc., and what the reality is of the modern world with its demands on consumptions, etc. And connecting those two things is going to be absolutely critical. And I'll give you an example. If we're going for a completely renewable future, we are going to have to start mining on a colossal scale to get the rare earths for the magnets for wind turbines, to get materials for the solar panels, etc. We're going to have to start scaling up an order of magnitude more mining to start delivering those new materials for this modern world. And alongside that, we've got a lot of issues still to kind of deal with. So from my perspective, one of the problems we're going to have is how we connect between these two areas. And one of the issues is that in geography, we have a kind of schizophrenic type of world. I mean, Hazel alluded to my kind of schizophrenia, but it's a schizophrenia in geography. We have these separate. We have this as the physical world, and we have this as, well, that bit there, say, as the human world. And yet that is completely ridiculous. Because there's absolutely no doubt that almost every bit of the natural world is now modulated to some degree by human action. That's why we call it the Anthropocene. Humans are now a process in the natural world. And there's absolutely no doubt that the kind of vitality and continuity of the modern world is absolutely constrained and limited by that physical world that's going to be around, whether it's climate or whether it's resources. And so to my mind, one of the things this tells us is that the historical artifact of having a physical geography and a human geography is completely pointless. It's a template for the 20th century that doesn't work in the 21st century. And so one of the things I think we need to seriously look at is we need to get rid of human geography and physical geography, and we need to call it geography. Thank you very much.